So last time I've been mentioning that one case where you want to use loops is when dealing with arrays. So what is an array and how does it work? Well, the kind of old school analogy is that your array, and in our case it's called my array, is a box in which you have index cards. Index cards that can store one value that's written on them, and they have an index, starting with 0 for the first card. Here is how these individual elements would be called. The array name, my array, the elements that are stored within the array, in this case 3 elements, the index of each element, starting with 0, and the value that's stored within each element. So in a more compact form without the analogy, this is what we're usually dealing with. An array which has a name and which has elements. In our case, 6 elements, with each element having its respective index, starting from 0, and a value it can store, in this case integer values. And the way you'd access an array's element is with this syntax here. So you could read out the array's second element by calling the array, then have these square brackets, and within those square brackets you just put down the index of the element whose value you'd like to read. Similar here, where we're reading the value from the element with the index 4, which is the 5th element here. So let's experiment a bit with arrays. I'll just drop down a geo here, dive in and delete the file, and add a single point, which I'm going to use to just store values on it. The point is not of interest here, so let's hop to the geometry spreadsheet and we will deal with the values we're going to store in here. So let's append a point wrangle, and within this point wrangle, let's first create an integer array that stores some values. And the way we do that in Vex is similar to when declaring a variable. So first we drop down the data type, in our case an integer, so it's int. Let's call this one my_array. And to tell Vex that we are not creating a variable which stores a single value, but an array which stores different elements, we append those square brackets here and then close this with a semicolon. So that executes without any problem, and let's just store this on our point. So the add syntax here is I for integer, then the square brackets to tell Vex that it's an array, then at, and let's call this my_array, and it should be equal to what's stored in my array called my_array. So nothing too different from what we've seen in previous tuts here. And we can see now in our detail view, we see an empty array called mayArray and not myArray. So let's fix that like this. Let's store some values in our array. And there are different commands for dealing with arrays. The most basic 2 commands are push and pop. So push adds an element at the end of an array, and pop removes an element from the end of an array. So let's try that out. Let's type in push and parentheses, and then I'm just going to open up the help page for push. So we can see this adds an item to an array, and it first needs the array and then the value it should add to the array. We want to add to my_array, and let's add a value of, say, 11. We can see now the array that's stored on my point now has this single value in here. So let's add a few other values. Like so. Let's drag this out here, and I can see my array has now 5 elements, 11, 22, 33, 44, and 55. So let's drop down another point wrangle here and try accessing those values. So first let's create a variable in which we'll load the array from the point. So again, int, let's call this one myArray2, and this one needs curly brackets here to tell Vex that it's an array, and we want to load in this our integer array that's stored on my point called myArray, like so. Nothing happened yet, so let's try accessing a value, and let's create a new integer, call it val for value, and it should be equal to my_array, and let's access element with the ID 2. And of course it's still not mayArray but myArray, like so. And we have our value here, and this is our array, this is the value. So ID 0, ID 1, and ID 2. That's the value that we just loaded from the array and saved it into our val. Also, just to be sure that we see if we modified the array by this operation, let's save it back. So again, I square brackets at my_array equals my_array. And we can see we haven't changed the array yet. However, what we can do here, instead of just using this simple access by ID, I can use the pop command. And again, let's just go to the help page. So pop in its simplest form just removes the last item from an array and returns it. So let's just give it the array where we want to remove the last item from. And we can see now our value equals to 55 and it's not stored in the array anymore. Let's try this a second time. Call this one val2. And again, call pop in exactly the same way. We can see now we have only 3 values stored in my array, but value 1 is the 55 and value 2 is the 44. So pop always removes from the end of an array. However, you can also tell it to remove a given index. So I can call pop with 2 arguments, the array name and then the index where it should remove something from the array. So let's call it with a 0, so it'll in theory remove always the first element. And it does exactly that. First, with this one here, we remove the first element from our array, which is the 11. And then again, we remove the first element. And as the 11 has already been removed, the first element in my array now is the 22. So just so you can see this is my array with only 1 pop command. So 11 has been removed from the front, stored into my val. And this is the second call of pop. So now again the first element has been removed, stored into my attribute called val2. Also there is a whole subsection in Houdini's help dealing with arrays. So there are lots of hints and lots of techniques for working with arrays and also for commands that you might often use when working with arrays. So I've been telling you that arrays kind of work hand in hand together with loops. So let's try this out and just copy those 2 point triangles over here. And let's just highlight the first one here. And instead of writing push 5 times, let's instead create a loop to fill this array. So let's create a for loop. And the first thing we always do in a for loop is declare and initialize our counting variable. So int I equals 0. And let's decide how long we want to run this. Let's say as long as I is smaller than 9. And let's increase I by 1 each iteration. And in here, I'm just going to do push my underscore array, comma, I, like so. And of course, this needs a semicolon. And now I can see I've filled my array with all those values coming in from my iterations here. So we're starting off with 0, and as long as I is smaller than 9, we continue running this loop. So we go from 0 to 8. Let's just store all the numbers from, say, 1 to 20 in this array. So let's start with 1 and check if I is smaller or equal to 20. And as long as that condition is met, fill the array with the current value of I. So I have this array of 20 values here, ranging from 1 to 20. Let's, in the second point triangle, sum up all those values in here in this array. So I still have those 2 pop commands here. Let's get rid of them like this. And again, let's create a for loop, which goes through each element of the array and sums it up. And in this case, it's pretty straightforward, as we know this array has 20 elements. So let's again create a for loop, which will run 20 times. So we initialize I to 0. As long as I is smaller than 20, let's keep incrementing I. So this should run 20 times. And just to check, let's set a value on our point to the elements value that we currently extracted from our array. So curly brackets I, like this. So we can see now when this runs, it stops at the last value. It extracts from the array, which is the 20, so it'll run through all of these elements. So let's just go over what we did here. We loaded in our array, which was stored as an attribute on the point, then created a for loop that runs from 0 to 19, which is exactly the IDs that we have. Keep in mind, we start with ID 0 here for the first element, so the 20th element will have the ID 19. And then we extracted the element with the current loop's counting value as an ID. So in the first loop, we extract the ID 0. In the second loop, we extract ID 1. Third loop, we extract ID 2, and so on and so forth, until we end up at ID 19, which has value 20. So everything is fine here. So to sum those up, let's, outside of the loop, create another variable, call it sum, and initialize it to 0. And in here, let's say sum plus equals the current array number. And down here, after we summed up all of these, let's create another attribute, in this case call it sum, and it should be equal to the value that we just stored in sum. So we can see now that all these numbers here summed up is a value of 210. Again, we initialized a sum variable with 0, and then for each iteration we read out the current element of our array and add it to our previous sum value. And after we iterated through all these elements, we write out this sum to an attribute here. So this was kind of straightforward, as we know exactly how many elements are in our array. But let's create another example. So add a second point here, and in our point triangle here, we can see we have both points storing the same array with the same length. But instead of giving it a fixed length here, let's create a new variable called maxIter for max iterations, and it's an integer, and it should be a random number generated from our current points number. And let's multiply this by 20 and add 1 to it. So it'll be between 0 and 21. And put that down here. So our loop runs maxIter times. We can see here in this case, for the first point it runs 9 times, for the second point it runs exactly once. And we can dial this in by adding a seed value here until we have something that we like. For example, like this. So 2 elements in the first array, 11 elements in the second array. And that is kind of problematic down here. In this case, it will yield the exact result, because even if we're trying to access elements that are not here, Vex will automatically return a 0. However, there might be algorithms in which it is important that you only iterate through an array as long as there are elements in this array. So here we are trying to extract 18 elements out of this array which are not there, and here we are trying to extract 9 elements out of this array which are not there. So how would you go about extracting those elements and going through this array so that no cycles are wasted? Well, what we first want to do is, after we loaded this array in here, we want to determine how many elements has this array. And we can use a function called len for that. Let's create a new integer, call it num_elem for number of elements, and it should be equal to len. And then we put down our array name into parentheses behind it. So this will return the number of elements stored in this array. And then what we can do is use this number of elements to tell Houdini that it should only execute this loop exactly as often as there are elements in our array. Like this. So nothing should have changed here. We still can see we've got the sum here, but this time we are only running the loop 2 times for this array and 11 times for this array here. And yes, there are other techniques of iterating through an array, and we will talk about them in a future tutorial. But for now, let's stick to that. So let's actually build something using these techniques. Again, create a new GeoNode, dive in there, and I'm going to drop down a grid onto which I will scatter some points. Say 100 for now, and let's disable the relax iterations so they have this kind of erratic placement here. Next, I'm going to drop down a point triangle, wire it up, and in my code, the first thing I want to do is, for each point, I want to look which points are close by, and I'm going to use a function which we use very often at Intagma. It's called nearPoints. So what nearPoints does is, it looks at your scene and determines which points are within a given distance to the point that you are working on. And it will return those points as a list of point numbers, as an array. So let's create our array, call it npts for nearPoints, and the curly brackets to tell Vex that it's an array. And in this array, we want to store all points that are nearby, and we find them with the nearPoints function. Like this. Again, hit F1, go into the help menu, and we can see there are several ways of calling this function. Let's start with the simple form here, so it needs a geometry stream that is 0 in our case, just the geometry coming into the first slot. Then it needs a position from which we want to search for nearby points, and a maximum distance within which we're going to search for points. So 0 for our current geometry, the first input slot here, then v at p, just the current point's position, and then a maximum distance. Let's call this one maxDist and create a variable for this, a float that is, call it maxDist, and it should be equal to what we set with the float slider. Then we call the float slider maxDist as well. Just create the slider here, pull down a bit, and we can see now we have this neat float slider here. Let's set it to 0.15. And just for debugging reasons, I'm gonna write out my array storing the points nearby, like this. So let's head over to the geo spreadsheet here, and we can see, well, we always only find one point. That is, maybe my maximum distance is a bit too small here. So let's increase that a bit and see what happens. So we can see now we are getting more points. And when I look at this array, there's something interesting happening. So for the point with the point number 0, it also finds the point itself. And that is because we are only searching from a given position within a given distance. And we are not including or excluding any point numbers here. And this is one of the caveats when working with nearPoints. It will always also return the current point number that we are working on. and in this case, it'll only find the point itself and no actual neighbors. And while this can be handy in some cases, what I want to do next is draw lines between those points. And drawing a line from a point to itself does not really make sense. So let's clean this up and just remove those points by just always removing the first element in an array. And we can either do this with pop or with another command called remove index. Doesn't matter which one we use. Just so you see in it, I'm going to use remove index here. And I want to remove from NPTS always the first element, that is the element with the index of 0. So for some points we now have an empty array, they just didn't find any points nearby within this given distance here, and for some points we have like 5 neighbors, and so on. Okay, now that we have this list of neighbors, let's create a for loop, and as you can see in the geo spreadsheet, the arrays are very different in their length. So some have 0 elements, some have quite a few. And to deal with that, let's again use a technique we already seen. So first let's create an integer, call it max iter for max iterations, and it should be equal to the length of the array that we just created. That means the number of elements in the array. So length of NPTS after we remove the first element, and then drop down this for loop. And then what we want to do is, we would like to read out the value stored in the array at the current counting variable's position. I'd like to call this npt for near point, because we're now extracting a single element from npts near points. So near point equals npts, curly brackets, I. And now all I have to do is add a primitive to our current geostream. It should be a polyline, and it should go from our current point, that's the one with ptnum, to this point that we just extracted out of our array. So npt, like this. No errors, let's go to the scene view, and we can see some connections happening there. And when we dial up the distance now, we can see new connections appearing there. Like this. So far so good, that seems to work. However, it sometimes is a bit clumsy to extract each array's length and then put that down into a for loop here just to be able to iterate through an array's elements. And luckily, Vex has another construct for doing this in a bit more compact way, and it's called a for each loop. So let's just duplicate this point wrangle here and use that one to demonstrate the for each loop. So let's just copy those 2 lines here and paste them down here, and I will just comment them out for now, and delete all that here. So when you are using loops to go through a list of elements, there's another way how we can write that. This time with a for each loop. So it is kind of similar to a for loop, however it only takes 2 arguments. One is an integer, in our case let's call it npt, then a semicolon, and the other one is an array, npts, like this. And what for each will do now is, it will go through this array, npts, as long as there are elements. And for each iteration, it will load a single element from npts into this variable, npt. So in our case, this loop will step through our list of points close by, and just successively load each element from our npts array after the other. And now that we've done this, we can just take this bit of code here, and paste it in our loop, delete these comments here, and that should yield the same result. Let's check. Yeah, exactly the same result. However, when you compare our classic for loop with our for each loop, the for each loop is way more compact. So that's what I tend to use when iterating through an array. So this is kind of the bare minimum that you need to know to be able to work with arrays. And most of the time we will use arrays to store point numbers of points nearby or neighboring points, that means points connected to our currently active point, and so on and so forth. Now, the way I set up this piece of code here is I can specify the maximum distance within which we will be looking for points to connect. But what if I want to set a minimum distance as well? Well, for that we need another control structure.